Hello guys, so in today's video I'm just going to be showing you, as promised, collisions of objects in 3D space. So we have our capsule, the code and the everything is exactly the same thing. So to do the collisions, currently we are not yet taking full advantage of the physics engines. We're just kind of pulling things together as we like, but we're going to move towards that. In the next two videos, I'm going to be refactoring some things. One of the things that I've done to these particular projects that I've added a virtual camera. A video on that will be coming out in the next 2 weeks. I think that should be next week. So watch that to be able to add the virtual camera so that the movement can be correct and it doesn't look wrong. Maybe I could press in W and it looks like it's going backwards. That's usually because of the camera position. So today we're just going to go straight into the collisions. So firstly, I'll just add a 3D object, a cube. Yeah, so for the cube, I'll just move it a bit forward. I'll move it in front of the of course, you can always check your main camera, and then this looks good. So I can just make this maybe the scale of the cube. I can just make this 3, and then make the Z3. Okay, that looks like a good enough cube. Um, and then to be able to see collisions well, um, okay, let's just go ahead with this. So if we play the game now, now if we play this game and then we press W, you can see that it's moving through the objects. Now, our player is not a ghost. We want it to be able to collide with this object and not move through it. So let's fix that very briefly. So to fix this, we just go into our player script. Then you can open it off if you don't have it open, but I already have it in open in Visual Studio. So this is just the code that we wrote the last time. So what we just need to do is to check for collisions. The first way that we're going to do it is by doing a raycast. It's one of the simplest methods. Of course, there are other methods in various places that a lot of people use, Euclidean distance and stuff. But we're going to use the physics engine in Unity. And like I said before, this is not taking full advantage of the physics engine. We're just trying to kind of pulling things together, hacking things together, but it's still okay. So we can use a boolean. Let's just make a boolean colliding, and then so we'll use the physics engine. So that's physics dot raycast. Uh-huh. So this asks about the function is overloaded about 16 times, but what we need is the transform dot position as the original point where our capsule is. Then we need the move direction, which we already defined actually up there. The move direction is just saying it's a vector that is telling us the direction in which our player is going to be moving, and we need the size of our player, which we could of course get from the transform, which we could get from the object itself if we just maybe got the component of the object. But then let's just make something really simple here. Our goal is to just get it working at first. Much down the line in those videos that I promised, we'll be doing optimizations for the physics engine. So like we saw in Unity there, we see that and check on the player, for instance, we see that it's 0.7. So we're just going to put the same thing inside here. So we can just 0.7f. So we have that. So we are checking if it's colliding now. So what we want to do now is that before we add, because this is the function that's responsible for its movement. Before we add this, we want to check if it's colliding. But our idea now is that if it's not colliding, then you can move. Then you can move. So simple as ABC, and this will give us movement within the object. It will stop. So whenever it collides with the box, it stops it at this point. And I'll go into some of the math that is necessary for this just in a moment. Okay, so as we can see, we've done that. So let's just play the game and see if our raycasting is working, and I'll explain the raycasting after that. That I will do is I'm going to change the size actually. Um, this is just for testing. This is the test. This side is everything that we change here wouldn't change it in the game. It will just be changing it within the play mode, not in actual in the actual whole game. So the reason why I'm changing it to 1.5 is because I want you to see something. So if we look at this actually, now it's bigger, of course. If we press it, now it's not going through the object. We move back, it's not going through the object because that raycast is finally identifying that, oh, okay, there's an object in front of it and it's not moving through it. But let's say I move to the side a bit, and this was the reason why I actually made it bigger. Now, if I go through it, you see that the object is still going through it. Now, this is happening, so we can just exit. And so now that we exit back, you see that everything is routed back to normal. So that's not a problem. Now, you see, now, I mean, of course, you're not going to maybe like make it bigger for some reason, unless maybe your game does that or your simulation does that for maybe whatever reason you choose to do that. But one thing that always happens is that even in that small state, if I move too much to the side, you notice that the player would now begin to move through the object. Now, why that happens is because of the raycast, how it works. So the raycast essentially is nothing but say I have my capsule, so it's like a laser that is at the middle, like this. It's at the middle of the cap of the player. So it casts an object, it casts that laser on the object like this, and it's saying, is there something? Is there something? Is there something? But then when, for instance, it's here, and then the laser is here. So the laser is no longer in the middle now. So anytime it now moves in this direction, say it's moving, it's moving. So now when it's moving in this direction, all this part of it will still cut through the object because now it's the cube that is supposed to be interacting with, colliding with, is no longer in its front. And so because it's not in its front, it believes that there's nothing there. Of course, this is not how physics works anyways. And if we had used the physics engine, all of this would have been taken care of. But uh, but then that's the problem. And there's another method that we could use. But before we go into that other method, I just want to cover the math that makes the raycast work essentially. Now, so this is a primitive way, and I'm not sure if that's how Unity implemented it. But essentially, what we're trying to do is to get the intersection between a line and about six planes. So what we need is, but we don't really need six planes. We can just optimize it and focus on like a particular plane. So like we've seen, we just need to focus on the boundary is the laser. So like the ray cast is like a ray or a laser, like a beam of light. So is it interacting with a boundary? That's what we need to focus on. So the formula is essentially ax plus by plus cz plus d equals 0. So now this represents the plane. So like if we had a cube, something like this because a cube usually has 6 faces. So this represents x, y, z. It represents all the planes. So it represents the x direction, the y direction, the z direction. And then this d is just the distance of the cube from original position. So it's just like normal y equals mx plus c, and then this just tell us the intercept and things like that. So it's something similar to that. So this is the equation that represents the cube. Now for the line, we just have a simple p equals like p naught plus td. And for this also, the p naught is just like it could be 0 based on where the position starts, but it starts on the object now, so it's mainly like transform the position, and then we're adding it to td. T is just like the actual is what we are actually using to get the point of intersection. So and then d is the movement direction, the vector of the line. So this is quite simple in this case. The d here is not the same as the d here, note. So they are two different things. Now in this case, what we're now trying to do is that we're trying to equate these two equations, and then we're now saying look for this t, because this t is the one that says what is the exact point of intersection. But we're not really concerned about the exact point of intersection here. We're just solving these two equations. So the equation of a line, in this case, like y equals mx plus c, the equation of a plane like the cube in this case, and then we're trying to find if these are intersecting at all. So usually we would have like a threshold and say that, oh, if it is above, if the um point of intersection is maybe above 0.2 or maybe 2 or something like that, that, oh, definitely it's intersecting. Because like if it's below the threshold, it could just be like it's not really intersecting. But all of this is still not a perfect method. The best method is to create, let me just clear all this. Now, the best method is to create a collider on this object, on this capsule object. So a collider is a kind of like a physics object that kind of surrounds this. So let's say we have our cube again. So what the collider does is, instead of having a line that can fall off the boundary of the cube, instead, in that case, we then have, let me just clean this away. Okay, so instead, in that case, we have a collider around this that like is the shape. So instead of projecting a line, then it just projects like shapes, 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 shapes. So it keeps, so in that case, the whole shape is captured within this. The whole shape is captured. So it doesn't now have that risk of maybe a little part of it is now running through the cube, even though we are checking for collisions. So let's just code that out. So what we would need in that case is a capsule cast instead of a ray cast, because a capsule is the shape of our object. Our object is actually a capsule cast. So we'll come back and fix that. There's some things we need to add to it, but what you want to make sure is that you have a capsule collider on your object, and of course your cube should naturally have a box collider anyways. So we go back here and we need to make some changes. The first thing is, let's just clear this out so that we can use IntelliSense. Okay, so the first thing that we need is the first vector, which is the transform dot position. So this just basically says that this is where the object is at this point in time, and then we need another vector, basically that says that this is how tall the object is. This is the position of the object with respect to its height. So it's just like, so when you look into the capsule cast, it looks towards the you basically look towards two vector points, the object's position, the object's height, and things like that. So what we just need to do in this case is transform dot position again, um, plus vector dot up times the player height. And I'll show you the player height now actually, because we already have it in the code. Not in the code, but in the editor. So then we also need a radius for the player. And then we need again the move direction, that is what direction is the object going to be moving in. So that's essentially what tells us what direction to look for collisions in. And then finally we are going to need the move distance. How far is the object going to move? So some of these have not been defined yet, so let's just make all that work. So instead of player size now, we can just make this player radius, which still remains the same, and then we can have float um player height, which is just two. That's already set on the collider. Now okay, this should be vector, so this should be vector 3 dot up. Okay, so what we need left is the move distance. So the move distance is essentially just this. That's just the move distance, the time times the speed. Remember, displacement equals times multiplied by speed. So move distance. So we can just make the move distance maybe somewhere like here. It's a float, move distance. Yeah, so we have this. Okay, and so everything is completely put in now. So that's essentially the capsule.cast. As I've said before, the capsule.cast, it just creates a cast, like a capsule object in front of it, and it just keeps checking. So of course, there's a maximum position it will check to, because we gave it a move distance, which is like the maximum distance that it's going to check. And if we say that the move direction is in this way, it's going to check in this direction. If we say the move direction is in this way, it's going to check in this direction. That's essentially how the capsule.cast work. Its formula is much more complex, and some of the formulas in the physics engine are much different from some of the things that I'm describing. But that's the general, what I'm describing is the general idea of how they actually work. So we can just go back to the game now and see the collisions. Okay, so in the game now, let's play the game. Okay, so now when we play the game, of course, you can't move through it again. You can't move through it again. But let's say we move to the side. Okay, it's not able to move through it. Let's increase the size again, like we did in that previous test. 1.5, 1.5. Okay, so let's try and move through it. You can see that even though it's to the side, it can't move through it. You see, it's still unable to move through it in this case because it's casting that capsule. So that capsule is still interacting with it. If it was the raycast would already be away from the boundary of this cube, and so it will not be interacting with it. So that's essentially how collisions work. Of course, like I said, because this naturally has a collider, a capsule collider, and the cube also has a box collider, there are better ways to do this, and you'll see that in the code refactoring that is coming in the next 2 weeks. So the next video should be about the virtual camera, how you can make a virtual camera that looks over your scene in the proper way. And then the next video after that should be about making use of the physics engine, taking advantage of the physics engine. So we're going to add a rigid body, which naturally adds its own. It basically builds in the physics engine into it. That is the rigid body, and so it just makes the physics much more simpler to use. Of course, there's a bit of a learning gradient there too, but it's going to be fine. So in doing this now, we have some basic simulations ready, some basic building frameworks by which you can use all these games, Unity, and we're going to be looking into Blender maybe sometime down the line to be able to explain physics and math. And hopefully by the time I'm maybe a year into these videos, people would have gained such a better understanding of physics concepts by being able to learn them intuitively from these videos. Thank you very much for watching. Have a nice day.